Hi, this is Deepak. Today I will show you the recursion tree concept. Recursion is the most important thing in daily use, and how it will work. How can we implement in our use? I'll show you. Basically, recursion means recursion. The function is calling itself again and again. Okay. One of the common example is Fibonacci series. Fibonacci series means if it will start from 0, 1, again 1, and 2, 3, 5, 8, 13, 21. How the series will work? Can you decode it? Basically, the previous term, how it will, the previous term, suppose it is n, it will be n minus 1 plus n minus 2, like that. If it is n means previous term is equal to n minus 1, next previous is n minus 2. Are you getting my point? Okay, I will show you how it will work basically. Here in a recursive function, if you will write fn is equal to fn minus 1 plus fn minus 2. Okay, that is the recursive function. If you put in code format, then put the first solution. I'll give the solution after. First of all, I'll put take a method. Suppose whatever I put in that, I think client will send the request. Client will want to know what is the Fibonacci of 5. Okay, that is the method. Return type is equal to integer. In recursive function, when is the base case where it will stop. If you will not put base case, a stack overflow error will occur. So for that, what will be the base case in that? If a greater than equal to 1, then return n. Okay, if client will send, suppose he will send the 0 less than or equal to 1, right? It will return 0. 1 less than or equal to 1, it will return 1, right? I hope that it will calculate, and I'll show you how it will calculate all those things. Here we can write f of 0 is equal to 0, f of 1 is equal to 1 here, right? I'll show you the tree diagram basically. Suppose client want to know about the f of 5, okay? I will calculate all those things. I will show you step by step. F of 5, okay? That is the base case only I put here. It is not yet completed. I return f of n minus 1 plus f of n minus 2. Okay, for that phi of 5. Phi of 5. I will show you. N minus 1. Phi of 4. Phi of 3. Phi of 2. Phi of 1. It will toss the base case, right? In base case, what we write here, if n less than or equal to 1 means return n. So it is n is equal to 1, less than or equal to 1 means it will return 1. F of 1 is equal to 1, right? Here, suppose it is the left side, LHS, it is the RHS, right hand side. Left hand side, already toss the base case, or you will configure the right hand side. For that, I get f of phi of 0. It will touch the base case, right? N less than or equal to 1, here n is equal to 0, 0 less than or equal to 1. Is 0 less than or equal to 1? Yes, return n. It will be 0. Again, we have to go to the right hand side. Here, what will we put? N minus 2, n minus 2, 3 minus 2 is equal to phi is equal to 1. Here, 1 we get, 0 we get, phi of 2 is equal to 1. Here we can put, here phi of 1 is equal to 1, already we get, right? That is 1. Here we get 1. Phi of 2 is equal to 1, 1, 1, 2. Phi of 3 is equal to 2, right? How? Here, phi of 5 is equal to, I'll show you here. It is, suppose it is the tall. 0, 1, 2, 3, 4, 5, 6, 7, 8. Phi of 5 should be 5. Okay. Here phi of 4 is equal to phi of 2. It is not a toss the base case. So we get phi of 1 and phi of 0. Phi of 1, we already get phi of 1, phi of 0 equal to 0. 1, 1 we can put here. Okay. Phi of 3, we get 2, phi of 2, we get 1, it will be 3, phi of 4. Okay. At first we backtracking, lastly we gave the value and put. Okay. Like that. The function calling again and again, that is basically called recursion. Here RHS what? N minus 2 means phi of 3. So phi of 3, it will be phi of 2, let's say phi of 1. Toss the base case, it will be 1. Phi of 2, phi of 1, phi of 0. Okay, P of 1 is equal to 1, P of 0 is equal to 0, 1 0, 1 1 2, 1 and 2. We get P of 3 is equal to 2, P of 4 is equal to 3, 2 plus 3 5, P of 5 is equal to 5. How? Through the tree structure I showed you, P of 5 is equal to 5. Here see 0, 1 2 3 4 5, P of 5 is equal to 5. That is the value. Okay, that is the top, that is the value. We get the answer. How it will recursively through tree I showed you. Okay, thank you. Right, here I already calculate the time complexity. How the time complexity and the space complexity will determine. I'll show you. Basically, I already made that one, but it is not the clarity one. So I'll show you. I already made that one. Basically, it will start from 1. That is the parent, and 2 branches will be there. If 2 branches will be there, there is a shortcut is there. If 1 parent will be there, tree structure. If 2 branches will be there, its formula time complexity will be 2 to the power n. But we have to determine, no? Everything we have to prove how it will 2 to the power n. Basically, that is parent. That is 1. 2 branches will be there. 2. Here 4. Like that, it will increase in geometrical progression up to the power n. Okay. Suppose here I will put. I'll show you here. Wait a second. Here basically 1 plus 2 plus 4 up to the n. 1 is equal to 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2, that is the exponential all starting from 0, so n should be minus 1, right? That is in geometric progression, right? 1 plus 2 plus 4. So there is a formula will be there. I forget that one, but e to the power n minus 1 r minus 1 formula, right? Is the common term, I think so. Not common term, that is the first. 1 plus r is the common term 2, n minus 1, 2 minus 1, 2. Okay? That is the 1 plus 2. Wait a second. Not. That is into that horizon. 2 to the power n minus 1, right? Basically, that 1, 2 to the power rn minus 1, no? 2 to the power is n minus 1. 1, 1, right? It is the constant. It is the constant. It will be 2 to the power n. That is the answer. And that is the time complexity. Space complexity, the height of the tree. The height of the tree, 1, 2, 4 up to n. That is the circle formula is there. For the time complexity, branches to the power height. Branches is equal to 2 branches will be there. Height is equal to n. 2 to the power n. Space complexity is equal to n. We already get the time complexity and space complexity and the whole scenario I mentioned. And how we will derive 2 to the power n. That is the geometrical progression formula. Formula is basically that is a r to the power n minus 1, r minus 1. That is here a is equal to the first term and r is the common term. Here we derive 2 to the power n. That is the thing how the recursion will work beautifully. I showed you. And time complexity, space complexity as well. Thank you.